Hey everyone, and welcome to this explainer. Today, we are going to completely flip how you look at the ground beneath your feet. We usually think of our planet as just this static rock, right? Just a permanent stage for human history to play out on. But the truth is, Earth is actually a restless architect. It is constantly, and I mean constantly, demolishing and remodeling its own surface. Which brings us to a wildly fascinating question. How exactly does a planet build itself? When you really think about it, it's a massive paradox. To create a towering mountain peak, a lush valley, or even a brand new island out in the ocean, the Earth has to rely on immense and frankly terrifyingly destructive power. Creation on a planetary scale, it's born straight from fire and force.
Okay, let's dive into the roadmap. First, we'll hit Earth's restless crust, then look at the anatomy of a volcano, followed by the forces of destruction and creation. After that, we'll check out geysers and hotspots, the making of mountains, and finally, the grand balancing act.
Section 1. Earth's restless crust. Because to really understand how the Earth builds, we've got to recognize that the surface of our planet is always on the move. Just look at this number, 75%. That is 3/4 of all active volcanoes on Earth packed into one single massive zone known as the Pacific Ring of Fire. It absolutely perfectly highlights the sheer, mind-boggling scale of our planet's volcanic activity. And honestly, what's wild to me is that only 10 to 20% of all this volcanic activity even happens above the sea surface. Most of the Earth's fiery construction is happening completely hidden away, deep in the dark depths of our oceans. Section 2, Anatomy of a Volcano. Let's zoom in from that massive global map down to the nuts and bolts of a single volcanic eruption.
So, way deep down inside the Earth, you've got the magma chamber. Think of it as a massive, highly pressurized vault of molten rock pulling from the asthenosphere. When that pressure finally hits a critical threshold, magma forces its way right up the main vent. Once it breaches the crater at the top and becomes lava, the architectural process officially kicks off. Successive layers of cooling ash and lava from repeated eruptions, that is literally what builds the towering shape of the volcano over time.
But the Earth doesn't just use one type of building material for every project. It's got options. Acidic lava is light-colored, super thick, and really sticky. Because it flows so slowly and solidifies quickly right in the vent, it acts almost like a pressure plug, which leads to those violently explosive eruptions. On the flip side, basic lava is dark, superheated, and incredibly fluid. It flows rapidly over huge distances, which is exactly why it constructs these gently sloping mountains and those vast flat lava plateaus. Section 3. Volcanoes, Destruction, and Creation. This brings us right back to the ultimate paradox of volcanism. It's simultaneously Earth's most terrifyingly destructive weapon and its absolute most vital creator. The destructive side is, well, it's absolute. Advancing lava can just swallow entire cities whole. We're talking violent earthquakes, submarine faults triggering massive tsunamis, and skies totally choked with ash. There are Plinian eruptions, which are the absolute most explosive kind, that can launch deadly ash clouds up to 50,000 feet into the atmosphere. And get this, the sheer volume of pyroclastic material a volcano spits out can actually act as seeds for raindrops. So you get these sudden massive thunderstorms right over the eruption, mixing heavy rain with volcanic ash to create devastating high-speed mud flows called lahars. But if we flip the script, we see the constructive force that follows all that devastation. Volcanism builds brand new landforms, islands, plateaus, majestic mountains. And that ash and dust that initially choked the landscape, it eventually breaks down to create literally some of the most fertile agricultural soil on the entire planet. Deep within the ancient volcanic plumbing, in these things called kimberlite pipes, we find massive deposits of diamonds. And today, places like Japan, Iceland, and the USA are actually harnessing the immense subterranean heat left behind by that magma to generate clean geothermal electricity. It's this wild, perfect cycle of destruction making way for life and resources. Section 4. Geysers and Hotspots. Let's shift gears just a bit here. We've talked a lot about massive mountains of fire, but the Earth has a few other kinda quirky ways of letting off steam. Literally. Two of the most fascinating alternative geothermal features are geysers and hot springs. With a geyser, steam and water get trapped in underground fissures under immense pressure. When that pressure finally maxes out, bam, the steam violently bursts out to the surface. It's an amazing spectacle you can see in places like Iceland and Yellowstone. A hot water spring, though, is way more chill.
The heated water just smoothly flows up to the surface. And what's really cool is that these springs are often painted in these incredibly brilliant, vibrant colors, all thanks to heat-loving cyanobacteria that thrive right around the vent. Then we have hotspots. These are the geological rebels. See, most volcanoes form at the edges of tectonic plates, but hotspots are intraplate events, meaning they pop up right smack in the middle of a plate. A hotspot is basically a stationary plume of intense heat rising up from the mantle. As the Earth's tectonic plate slowly slides over this stationary blowtorch, the magma punches through and creates a volcano. But since the plate keeps moving, that newly formed volcano gets carried away and goes extinct, while a brand new one forms right behind it. It's essentially a planetary conveyor belt creating long lines of islands. That is exactly how the Hawaiian Islands were built. Section 5. The making of mountains. All right, so we've seen how fire builds the Earth. Now let's look at raw mechanical force, the colossal power of orogeny, or mountain building. Orogeny is the process behind the absolute most epic structures on the globe, and it is entirely driven by compressive forces. Picture two incredibly massive tectonic plates just slowly bulldozing into each other. As they converge, this sedimentary rock strata trapped between them is put under unbelievable pressure. And the rock doesn't just snap, it buckles, it crumples, and it squeezes upward. This slow-motion collision is exactly what created massive young fold mountains. The towering Himalayas, they were built and are actually still being pushed higher today by the Indian plate smashing into the Eurasian plates. But hey, not all mountains are folded. Contrast those fold mountains against block mountains. While fold mountains are squeezed upward, block mountains happen when massive blocks of crust are literally broken and shoved straight up or straight down by faults. The uplifted blocks become mountains, which geologists call horsts, and the blocks that drop down form deep valleys called grabens. The Great African Rift Valley is a total textbook example of this. You've got these towering horst mountains flanking a plunging deep graben valley.
Section 6, the Grand Balancing Act. With all this incredible weight being constantly shifted around, volcanoes erupting, whole continents crumpling into massive mountain ranges, you've got to wonder, how does the planet stay stable?
Well, this grand balancing act is called isostasy. It's the mechanical equilibrium between our heavy, solid crust and the hot, semi-fluid asthenosphere beneath it. Think of the crust like a giant loaded cargo ship floating in the ocean. When you add weight to the crust, say by folding up a massive new mountain range, the crust literally sinks deeper into the mantle below to balance the load. Conversely, as millions of years of wind and rain erode that mountain away, unloading the weight, the crust slowly bobs back up. The Earth is constantly readjusting itself to maintain perfect harmony. Which leaves us with this final thought. We've journeyed from the deep, pressurized chambers of fiery magma all the way up to the towering, folded peaks of the Himalayas, and we've witnessed the incredible, relentless mechanical forces that govern our world. So the next time you look up at a mountain peak, what are you going to see? Are you going to see just a static, permanent rock? Or are you going to see a temporary structure, a beautiful, fleeting moment right in the middle of a restless planet's endless balancing act? Thank you so much for joining me for this explainer, and keep your eyes peeled on the ground beneath your feet.